Breaking news. We're here at the Higley Institute where science fiction is becoming a reality. The U.S. government has charged the Institute with creating literal human super soldiers, individuals who have been made into giants by means of a complex and unprecedented enlargement process. This enlargement ray would hypothetically be able to produce a soldier with more muscle, more strength, more neurons, and more power. The study has proven quite controversial and has been widely criticized for being both unethical and scientifically implausible. Evolutionary biologist John Tyler Bonner calls this study a farce and utter garbage with no regard to basic biological scaling. Nevertheless, work on the enlargement ray has continued. But before scientists make use of this shrink ray on humans, they will be testing it on another subject to investigate its effects and possible dangers. As is often the case, we turn to the rat. In this special, we will be on site investigating the very first use of the ray on a lab rat, Rattus norvegicus. It is important to note that rats and humans differ greatly in both surface area and in mass. Rats live and function at a faster pace than humans, with a higher heart rate, faster metabolism, and more frequent reproductive rate, and a shorter lifespan. Norvegicus features a high surface area ratio, as small animals tend to do. Because of this, the rat is covered in a layer of soft and fluffy fur, perfect for thermoregulation and general adorableness. Their tail also acts to regulate body temperature by dilating and contracting blood vessels. In many ways, because of their size, the rat's reality is quite different from ours. At the same time, we have much in common with Rattus norvegicus, and much to learn from them. We turn now to our host, Lily Zwan, who will be conducting pre- and post-enlargement interviews with the specimen in question for this momentous experiment.
So, how does it feel to be the first rat undergoing this transformation?
Well, in some ways I'm kind of used to this kind of thing. They're always using me for some experiment or another. We rats are quick learners and easy to get along with, making us perfect subjects for understanding medicine, genetics, psychology, and all the other stuff.
Tell me, are you nervous about the procedure?
I am pretty nervous, actually. I mean, I really don't understand why this has to be done in the first place. There are a lot of qualities of my size I really rather enjoy.
Really? Such as?
Well, for example, gravity just isn't really a huge issue for me. You know, force of gravity is defined as mass of an object times the universal acceleration of gravity, 9.8 meters per second. Because my mass is so small, I really don't feel much of the force of gravity at all. In fact, my force of gravity is only about 4.9 newtons, whereas for you the force of gravity is 865.3 newtons. I really pity you guys. That must be rough.
So what does that mean for your everyday life?
It means I'm practically invincible. My good buddy Haldane once said, to the mouse and any smaller animal, gravity presents practically no dangers. You can drop a mouse down a 1,000-yard mineshaft, and, on arriving at the bottom, it gets a slight shock and walks away, provided that the ground is fairly soft. A rat is killed, a man is broken, a horse splashes, morbid stuff. I mean, don't want to test my luck and find out if he's right about rats, but the principle is there. To small animals like me, gravity poses no threat.
That's very interesting.
Oh, and another thing.
And what's that?
Not to toot my horn or anything, but I'm really strong.
Really? A rat? That's not what I would expect.
Yeah, you see, it's all about proportions. For my size, I can bear much more weight than you could.
Is that because forces that a muscle can produce are proportional to cross-sectional area L squared, whereas body mass is proportional to L cubed? Meaning that the ratio of an animal's ability to generate force scales roughly as 1 over L?
Exactly. Smaller animals are proportionately stronger.
Tell me, are there aspects of your current size that you are unhappy with?
Ugh, my eyesight is pretty bad. You know, just don't have a lot of cones and rods in the old eyeballs.
I can see how that would be frustrating. Speaking of lack of cells, don't you have many fewer brain cells because of your size? I'm surprised that you're even able to communicate on such an intelligent level. Well, it's about time for the procedure to take place. Do you have any last words, Mr. Rat? I'm here today with our very first subject, post-transformation. So tell me, how does it feel to be a human-sized rat?
I'm gonna be honest with you. It's a lot more uncomfortable than I thought it would be. Is it really hot in here?
I don't think so.
Oh my god, I'm sweating. It's so hot in here. Can you give me some water? Something? This fur is so hot.
Are you okay?
You know what? Do you mind if I just need to take off some of this fur. I do not need it.
Are you sure? Is that healthy?
Yeah, you know what I think it is? My metabolism is just too high for my current size. You see, when I grew from rat size to human size, my surface area through which I lose heat went up by a power of 2. But my volume through which I generate and retain heat went up by a power of 3. So my body is generating much more heat than my body can diffuse across my skin. My tail helps a bit, because it provides a hairless surface with which to thermoregulate by either dilating or contracting blood vessels. But man, my heat regulation is just out of whack. Man, this fur is too much. No thank you.
Wow, that's a shocking amount of cognitive skill for a rat.
Did I mention? Now that I have so many brain cells, cognitive reasoning is a breeze. Thanks, Higley Institute.
I would imagine you can see a lot better now too with all those new rods and cones. That's wonderful.
I don't even need my glasses anymore.
That's great.
You know what's not so great? Gravity. I'm so heavy now.
Be careful.
I can barely move. My bones.
What's wrong? What were you saying about your bones?
Elastic buckling. In order to function at this size, my bone diameter would have to increase disproportionately. Mechanical stress literally causes my bones to snap. Additionally, because of my disproportionately small lungs, not enough surface area, diffusion of oxygen into system.
Well, I think we can agree that this experiment was an utter failure. Future procedures will have to take into account basic methods of biological scaling.